as we're analyzing our data, one thing that we should be analyzing is our residuals, or how well our predictions are. There's one of those conditions that we need to be checking before we actually use our data. We want to know whether there's a pattern in our residual plot. So we need to calculate a residual plot. What we're going to do is we're going to go to stat, and you're going to do a regression, simple linear. But now, when we take our x variable and our y variable, we want to select a graph of residuals versus x values. So we're taking those residual calculations and we're plotting it against each x value. And when we compute, we get the scatter plot, but we also get a regression equation or a residual line. So we put those data in, and we want to know whether this is a good residual plot or not. Well, actually, this is a terrible residual plot because there's a clear pattern shown. It is a quadratic pattern. If you traced the points, connected the dots, you would see that that's a U shape, which is bad. Here is that data. Again, if I was to connect the dots here, I would see that this has some sort of relationship that is not linear because there's a pattern. And really what we want is we want there to be dots that are equidistant above and below the line. So this is a bad graph. You want no pattern. Now we're going to calculate a residual plot for the worldwide gross movie. And we want to graph residuals versus the x values. Again, we have that same regression table. We have our scatter plot, and now we have our residuals. And remember I told you there didn't want to be a pattern. Now, there doesn't seem to be a linear or a quadratic pattern, but there is a lot of clumping to the left-hand side, which isn't the best. What do you think would be some other variables that would contribute to worldwide gross of a movie? What's going to cause a movie to make money or not? That's something where you could start thinking about your confounding variables or lurking variables. How much of the variation in worldwide gross can be attributed to the budget? That is calculated by looking at R squared. We've been looking at R, our correlation coefficient, but when you start to throw in the word variation, what that means is you're looking at R squared. Going back to our data to the right here, we have R squared. So that is 0.558, which is 55.8%. So 55.8% of the variation can be attributed to the linear relationship between worldwide gross and budget. But everything else, how much variation is attributed to other factors, would be 100% minus that. 100% minus 55.8% gives 44.2% can be attributed to other things. So the R squared is between the linear x and y variables, and then the other calculation is for all of the other variables. One last thing we do to measure the fit of the line is to look at the standard deviations of the residuals, or the sum of squared of errors. The standard error of regression is S sub E is equal to the square root of SSE over n minus 2, which is very similar to the formula for standard deviation, except we have n minus 2 degrees of freedom now. So SSE stands for the sum of squared errors. And what this means is, this is the size of a typical error for predictions. It roughly measures the average distance of points about the regression line. Now, S of E is equal to the sum of squared errors over n minus 2. So we would need the sum of squared errors over n minus 2. And that would give us 115.40741. I know that the sample size is 5,222, but where is SSE found? It's not in this little snippet right here. We actually need to go back to the previous line here, and you'll find it in the analysis of variance table where I have error and SS. That's the number that we're going to use. And that gives us about 115.4. And you actually won't have to calculate SE by hand. You'll always be able to do it with the regression. And that's all I have for Module 13.